Okay. Um, so once we've done multiplication and that sort of brief detour into powers and roots, we'll come back to division. The form here, so if I've got a over b and I'm dividing it by another fraction, c over d, what's going to happen is, rather than sort of learn a new process, is what we're going to do is we're going to flip the second fraction. This is called taking the reciprocal. So this is going to be a over b. We're going to flip this second one, right? So then this becomes d over c. And then we're going to change the operation from division to multiplication. The idea here, right, is that sort of multiplication and division are sort of opposite operations to each other. And a reciprocal fraction, right, is sort of an opposite fraction. You're flipping, right, the role of the numerator and the denominator. So this is kind of a case where you do the opposite operation to the opposite fraction, and it's sort of like a double negative, right? You're sort of doing two opposites, and so you get a form that you can work with, a multiplication form, and it should be equivalent to the one that we started with. Let me sort of show you some examples, right? It's always easier to actually sort of see this with some numbers. So let's take something like 16 over 25, and let's divide it by, I don't know, how about 12 over 15, for example. So what's going to happen here? Sometimes people call this keep, change, flip, right? You're sort of keeping the first fraction as it is. You're changing the operation from division to multiplication, and then you flip this other fraction, right, to sort of 15 over 12 instead. And so the idea is that rather than sort of learn a new process, again, you change it into something you already know how to do, right? We did multiplication 2 videos ago, so of course now we're experts, and we can sort of take the problem on from there. Once it's sort of rewritten, we can sort of do our usual thing and look to reduce it. Factor these guys apart. 16, right? 4 and 4, 25, 5 and 5. 15 we can call 3 times 5. 12 we can call 3 times 4. I was going a little fast because one of the things I just noticed is, in addition to things like the 4 here, and then 5 and 5, I actually set us up with 3's over top of each other. 12 over 15 is actually not in lowest terms. If that happens, that's fine, right? I mean, that can happen, right? You can, especially if you're just sort of pulling numbers out of a hat to a certain extent. So in this problem, almost everything reduces away. We're sort of just left with 4 over 5. This in some sense just becomes 1 over 1, right? I mean, if we're sort of reducing things away, we're doing a division, so if we divide, we're going to be left with 1. But, 4 times 1 is 1, 5 times 1 is 1. So we kind of end up here at 4/5, kind of exclusively just factoring and canceling. We actually don't really do any multiplication. You can argue canceling is essentially division, so I can't say that we're not doing no multiplication and no division. In some sense, we're doing a little division here, but it's this sort of factoring and reducing style. Let's look at another example just to make sure that we're okay with this format. How about something like what kind of numbers haven't we used yet? Maybe 20 over 27, and let's divide it by 50 over maybe something like 18. Let's kind of start with that. So the first thing is just to rewrite this, 20 over 27. So that stays the same. Then we're going to flip our operation from division to multiplication, and then we're going to flip our fraction. Maybe I should say change the operation, right? And then flip the fraction. So this sort of keep, change, flip idea, right? Keep the first thing the same, change your operation, division to multiply, and then flip this fraction to 18 over 50. Once we've done that, we can sort of look to start taking these guys apart. What are we going to have here? 20 would be like 4 times 5, 27 is like 3 times 9. We'll try to look maybe for common things. 18, you could do 3 and 6, but you could also do maybe 2 and 9. I'll try to get these 9s out of here. 50, right? We could definitely do 5 times 10. There's still some stuff here that could reduce, but let's just sort of start with this and then go from there. 5 and 5, 9 and 9. What are we left with? 4 times 2, 3 times 10. So we could do 10 is 2 times 5, and then I could do 2 here and 2 here, 3 and 5, and then 4. That's going to kind of be it, right? So this would be 4 over 3 times 5, be 4 over 15. So our final's going to look something like that. Oops, sorry, this is kind of a little crooked. That's the basics of the setup. Let's do sort of one more like we did in the multiplication. We can do this same kind of thing. We can throw some variables into the mix. Let's just sort of see what we got. We'll do sort of one last one. This process is going to sort of still be the same. We're not really sort of changing our process here. Let's do 8 AB squared over, I don't know, 25C. Let's divide this by, how about 24B over, let's do 35C cubed. Something kind of like this, right? 3 different variables, a couple different powers. We're kind of throwing the kitchen sink at this one. So just like we did before, let's do, right? First one stays the same. 8AB squared, 25C. Change our operation, so this would become multiplication. Then we're going to flip this other fraction. So then 35C cubed, and then 24B. Next stage would be starting to pull these guys all apart. A would be 2 times 4, A times B squared, A times B, 25, 5 times 5, C is C, multiply 35, 5 times 7, C cubed, C, over 24, B squared, I'm sorry, 24 just B, right? So 4 times C. As always, right, we didn't quite take everything down totally to their primes. You can do that. Sometimes it's maybe just tricky to kind of do it on the fly. So I kind of end up doing sort of a partial reduction and then canceling what I can and then just sort of doing a second or third round if I need to. Stuff that sticks out, 4 and 4. Variable value, I could do a B for a B. I've got a 5 and 5. I could do C here and a C here. What's left over? 2, A, B, 7, C, 5 and 6. So this kind of becomes 2 times A times B times 7 times C times C. So that's a decent chunk of stuff over 5 times 6. And so what we can do here, the only thing that would cancel and sort of break apart anymore, 6 would be 2 times 3. That gets us just one last thing here, right? I can cancel a 2 for a 2. Everything else here is just going to stay. So what's my final answer going to be? 7 A times B times C squared, right? Single A, single B, and then double C, over 5 times 3. Just can't get rid of that 15. Keep getting 15 on the bottom. That is not on purpose. That's just a coincidence. So that's the basics of the process, right? That's what our division looks like. The idea is you're sort of taking it, taking division, turning it into a multiplication problem. That's a great, like, sort of general math strategy as we learn new math concepts. Really what we're trying to do is sort of in as few steps as possible get from a new thing back to something we already know. In this case, sort of taking division and trying to then sort of reconceptualize it as a multiplication, which is something we've already been through. So that's the basics. We'll call it there.